I've always wanted to garden, and I've tried a few times, but kind of failed every time. I mean, it's hard. You know, you go travel for a week and the plants die. You get busy with life and the plants die. You get a little lazy and the plants get overgrown by weeds. Kind of everything can go wrong, and it's very hard to get it right. I studied mechanical engineering. I wanted to learn more about agriculture, and I took an organic ag class while I was in school, and that kind of started me off in this direction. So this is FarmBot. It's the world's first open source farming robot. It's like a really big 3D printer, but for plants. So FarmBot moves around in the space and it plants the seeds, and then it waters them. It also uses sensors to learn about the soil and the plants and the environment in order to farm smarter. It's all controlled with your phone or your laptop or a tablet from anywhere in the world. FarmBot has this tool head here, and it can pick up different tools. And these tools magnetically hook onto the tool mount right here. So FarmBot can pick up whatever tool it needs to use for the task at hand. So this is the seed injector. This is a 3D printed part, and then it uses a vacuum pump to suck air up through here, and then it kind of suction holds the seed. And then it goes and puts it in the ground, and then turns off the vacuum pump, and then the seed is left. This one is the watering nozzle, so it basically takes the input of water, and then it creates kind of a shower. It diffuses the water. This one is a soil sensor. So this is a $5 soil sensor that measures the moisture content. It does that by you stick this in the ground, and then it measures the electrical conductivity in the soil between the two probes. So then FarmBot can actually learn how much water is in the soil, and based on the plants that are planted, how much water should it add. And then it could also tap into the weather. So, you know, if it's going to rain tomorrow, well, let's adjust our watering schedule to farm smarter. And then all of these tools are stored down in this tool bay right here, and that's what allows FarmBot to automatically pick them up and put them away as needed. So you don't actually have to be out here doing anything. It just sort of picks up the tool when it needs to do something, and then it does that thing, and then it puts the tool away. For me, at least in my experience, the difficult part about growing food is being diligent with it. You know, it's not hard to plant seeds in the ground. It's not hard to spray the hose. It's hard to do that stuff every day though, and to do it well. You know, especially today with modern lifestyles, people want to go travel. They want to see their friends and family. They have jobs that they need to go to where they can't mess with the garden all day. So we have this web application that allows the user to control and configure FarmBot. So here's the basic controls of the web application. So this is if I want to just move FarmBot manually, kind of like a video game, where I can press these arrow keys and FarmBot will move in that direction. And there it goes. This is really only useful for impressing your friends when they come over, because obviously you don't want to sit here every day pressing these buttons controlling FarmBot. What you want to do is you want to program FarmBot to be more automated. And so that's what we've built into the software, is ways to combine these basic operations that FarmBot can do into custom sequences. But with the sequence builder, you have these basic operations. You can move. Right pin would be to turn on the vacuum pump or the watering valve. Read pin would be to read a sensor, like the soil sensor or an ambient air temperature sensor. You can also wait, so you could turn the water on, wait a certain amount of time, and then turn it off. And we're working on an if statement, so you can do logic-based commands. So with these basic blocks, you can create a sequence where you do a very complex action, where you just combine the different sequences. So let's see. This one is called pick up the watering tool. There we go. So where FarmBot will first move to an absolute position right above the watering tool. Then it's going to move down 13,000 units. And then it will pull the tool out 500 units from the tool bay. And then it will move up. And then now I can have a sequence where it goes and does all the watering for me. In addition to being able to execute that sequence on demand, you can schedule it to run every day at 4 a.m. or every other day or every week.
Does it know where the plants are?
Yes, it does. So FarmBot knows exactly where it planted the plants, which then allows it to know where they are for watering and what type of plant it is, how old it is. What's really cool too is because we know where we planted the plants, we know what plants that are in that bed that are weeds that we don't want in the bed. So FarmBot has a camera on the Z-axis there that can detect weeds and then remove them. We take these pictures and we find all the green things on the brown background, and then we say, okay, well, these are the ones that we know we planted there, and these are the ones that we didn't plant there, so those are things that we don't want.
Weed suppression. Weed suppression is just...
It literally just pushes the weeds back under the soil. When a weed is really small, it's really fragile and doesn't have a lot of energy. So if you push it under the ground or disrupt the root system, it's not going to survive. Weeds are really only a problem when they become bigger, and then they're harder to pull out and they're more established and have these root systems that keep it coming back. But if you get them when they're really small, then they're actually really not a problem. And that's what FarmBot is so good at doing, is it's a robot, so it never gets tired and it never gets bored of doing the same thing over and over. So, you know, you would not bother to go and pick out weeds that are this big, you know, because there's gonna be thousands of them. But FarmBot doesn't mind. FarmBot will go and do that. FarmBot kind of takes care of them before they're a problem. So in here is the electronics box. FarmBot is really just a really big 3D printer, but for growing food. So we have the Raspberry Pi computer, it's about a little $30 computer, and that's the brain of FarmBot. And then on the right is a microcontroller, the Arduino, and it has a ramp shield, which is a really common accessory that goes on top of the microcontroller, and it's used in 3D printers. And then these stepper motors, which allow it to move in the 3 dimensions. And then on the back is a rotary encoders, which allows FarmBot to know if something goes wrong. So sometimes FarmBot will be moving and there'll be a plant in the way, maybe it gets on the tracks, or there'll be some stick that got kicked up by a bird and it will be on the tracks. And then FarmBot will be moving and it will get jammed on that. These rotary encoders allow FarmBot to detect that something has gone wrong, and then it can alert the owner via email. And what's really cool is these tools are pretty low cost and they're simple. These are just 3D printed pieces of plastic that you could make at home, and we've published the design file for this, so you can design whatever it is underneath here that you want. If you want to have a laser that can destroy bugs and cut up plants, you can do that. If you want to have something that mists your plants, you can do that. If you want to have a soil sensor that measures pH and temperature, you can do that. These tools are just the beginning. What we've really tried to do with this project is build a platform that is both hardware and software based, so that people can design their own tools, use the software to tell FarmBot to farm in any way they want to. So this is all soil-based growing, but maybe you could use FarmBot for hydroponics or aquaponics. What we want is people to experiment with this technology, and that's why it's all open source. And it's open source, meaning that all of the design files, the documentation for how to build it is free. So anybody can download the files, look at the step-by-step assembly instructions online, and build something like this in their front yard or in their greenhouse or on a rooftop, and then tailor it to their needs. All right, so my office is upstairs. So this is the attic layer. This is my little desk. These are some parts that are actually printing right now out in the shed. So these are these little clips that are made of plastic, which, let me zoom in on the CAD model here, are these parts right here that are going to be used to hold the Z-axis cable carrier to kind of keep it in check. And this is just the computerized version of FarmBot. And then down here, here's all the components that you need. And then here's a step-by-step photo documentation that shows exactly how to put one of these together. So all of this is available for free for anybody to do this themselves. And I really feel like in today's world, you can do anything with the internet. You can load up a 3D model. Yeah.
And so what was your first idea? You were sitting around thinking, God, gardening's hard. And then you thought, I can program. Why not put the two together?
Actually, the idea came from when I was in the organic ag class. Specifically when a traditional farmer came in and gave a guest lecture talking about some of the tractor technology he's using on his farm. And I looked at that and said, wait a minute, I can do that better. And that's where FarmBot was sparked from.
How old were you?
22.
It's pretty amazing that actually no one else had come up with something like this.
You know, I was pretty surprised by that too. The first thing that I thought of when I thought of the idea is like, oh, this probably exists. Let me go look it up. And I scoured the internet. I was amazed actually that there was not a CNC type farming equipment already existing. And so I said, well, I guess then it's up to me. Okay. This was the very first FarmBot prototype made out of steel and these garage door wheels and a trowel. You know, this is so far from what we have now. This seems so crude and honestly a tribute to actually traditional agriculture. Made out of steel, heavy, not very high tech.
It shows how we haven't really progressed that far with technology.
Totally. As far as big agriculture goes, there are other robots and mechanized machines, but they're really expensive. They're meant for a huge mega farm, and usually they're also free driving. They are like a big tractor that doesn't have a driver. FarmBot's a very different approach. This is much closer to a 3D printer than it is to a tractor, where you can build it yourself and you can build it at home. All right, let's slide it over slowly. There we go. And you have complete control over how you use it. All right, how does it look? And so that's what we're hoping to do with FarmBot is let's figure out something new that takes the best elements of all sorts of systems, the best elements of the home garden. What are the best elements of the home garden? It's local. You have a say and control or agency in the system itself. That is nice. You get to grow things exactly how you want them to be grown. What's really great about a big mega farm? It's really efficient and it's low cost for the output. So right now, if you push this, kind of torques it. And it's automated, so you have very few people growing tremendous amounts of food. Those are all good things. So if we take the best elements of different food systems and we create something new with it, I think you get something like FarmBot, which is automated, it's open source, so it's shareable, it is low cost, it's precision and efficient, all of those different elements. So FarmBot right now is a kit. So we're selling these kits where all the different parts come in a box and we have assembly instructions. And if you don't want to buy a kit, we also show you where you can buy everything, or you could manufacture your own parts. In general, there's 3 or 4 main components. The first one is the tracks along the raised bed, and they're made of these aluminum extrusions, as well as these aluminum plates here that allow it to be attached together. Then this is called the gantry, which is kind of the main component that moves along the tracks, and that's moving along in the x-axis. This plate right here, it allows FarmBot to move along in the y-axis, and then we have the z-axis here, which is also made of an aluminum extrusion and this lead screw with a motor up in here, so then FarmBot can move up and down. And the last bit is the universal tool mount down here, where FarmBot can pick up the tools.
And it should be on like a raised bed that you can then, because you have tracks, so.
It doesn't have to be. The raised bed works pretty well here because the native soil here has a lot of clay in it, so it's not great for growing. But if you have good soil, you don't need a raised bed. You could just attach the plates directly to a post. Or if you have a greenhouse or some fence structure, you could attach the tracks to that. The raised bed is kind of a universal, put it wherever you want, but you don't have to use that if you don't want to. You could manufacture your own parts, so all of the plastic ones are 3D printable, and we designed them for DIY hobby level printers. The plates right here you could make with just a drill press and a hacksaw, or maybe make them out of plastic with a laser cutter. A lot of this you can make at home or at a makerspace with some very basic tools. In here is the 3D printer. It's printing out components. So down in here is this gray resin. There's a laser that is firing under there that is drawing out the part. And then this build platform will move up a little bit and draw the next layer. And then out comes the functional parts like this. So if you look really, really closely, you can see the layers, but the resolution is really good, so it looks and feels like a normal plastic part. The nice thing about this machine is it's really easy to use. I can send the file over Wi-Fi and it starts printing. I don't have to mess with it in any way. It just works. But if you look up here, This is all of the old FarmBot parts. So these are a bunch of different versions of the universal tool mount over the last 3 years. This one has a single magnet in the middle versus 3 magnets. This was one of the original seed injectors. It was kind of big and ugly. I don't even know what this one was. And then just all sorts of random old parts that we used for a few months or even a few hours, and then we said, oh, well, that didn't really work, so let's print out a new one.
I mean, that's talk about iteration.
Yeah.
Hourly iteration.
Hourly iteration, yeah. So this is the last 3 years of parts. The ability to create parts every single day, relatively low cost, and each of these parts costs about $5 in material. The utility is indispensable for a hardware project like this. These are all of our prototyping parts, which is actually a fairly small amount because we've reused a lot of the components over the years. We haven't really switched motors. The motors, the power supply, the Raspberry Pis, they're all pretty much the same. We've stuck pretty much with the same screws. It's the M5 screw, and it doesn't really get old. It's made out of stainless steel, so it never rusts. And so we can reuse them from prototype to prototype. We have a bunch of things that we bought that we didn't really use. Like you can see up here, these wires and stuff that we thought, hey, maybe that will work. And then it turned out that it was way bigger and way more yellow than we hoped for. So we didn't want to use that one. Some of these like vacuums and random things we bought and we weren't sure if we're going to use them, but that's part of the prototyping process is you acquire a bunch of materials and wires and electronics and screws and you see what works and see what doesn't. So here's the newest version of the tool mount and the seed injector. The O-rings are a little bit different, and where the water comes through is slightly different. The screws, it's a minor change, but I'm using different screws which have a lower profile head, which allows the magnets to get a little bit closer to each other, which gives it a little bit more holding power. Minor changes, nothing crazy different, the same concept overall. And then also these parts are functional too. It's not just a prototype. As you saw there, we were growing plants and FarmBot was functioning with 3D printed parts that you can make, you know, with a machine right on your desktop or in your garage or shed. So
these are your tools. I mean, you don't need...
Yeah, really all you need to assemble a FarmBot is a little socket wrench and a hex driver, and I think some wire cutters, and that's really it. Everything goes together with these basic tools, unless you want to really manufacture your own FarmBot. Then you'd need a 3D printer or a saw or a drill press or something like that.
What's the frustration level one has to have in order to just put together this sort of idea?
You have to be dedicated. I think there will definitely be frustrating parts about FarmBot, especially right now, because it is so new, because it doesn't have the greatest software in the world yet.
Oh my god. Ay, ay, ay. Why was that? It's supposed to be in the center. What happened there?
So you need to be diligent in saying, all right, I'm gonna make this a project. I really wanna grow my own food and I really like FarmBot. I wanna deal with the shortfalls right now in order to progress the technology. You know, eventually we'll overcome all those challenges where there won't be hardware problems, there won't be software problems. It kind of just works. Like the home appliance. You get a refrigerator, you plug it in, and you open the door and you put your stuff in. It's pretty simple and anybody can figure it out. That's what we want to work towards with FarmBot, but it'll take a while to get there.
How big could this be? Could we be growing really almost all of our vegetables?
I think so, yeah. So I've calculated that with a system this big, this is enough vegetables for one person. There's a big difference between growing all of the food you need, like all of the calories, and all of the vegetables. That's a almost 10 or 20 times difference in area. Growing all of your calories is really hard to do, but growing all of your recommended vegetable servings is very feasible, and that's what this system is tailored to.
The scale of this, your idea is to keep things at sort of this size?
So this, I think, is the smallest size that FarmBot makes sense at. FarmBot can definitely go bigger. You could make these tracks longer, you could make the gantry wider or taller to support larger plants, which is prototypes that we're working on and that we want to develop as well. This one is 4 times the size, so it's twice as long and twice as wide. And really all we've put up so far is the tracks. But we think that more or less the same hardware can scale to at least this size. With this, we hope that this size device could feed a family of 4 continuously, all of their vegetable servings throughout the year. And you could set up the water to a big pond or a tank somewhere if you don't have municipal water. This one's pretty exciting for us. It's obviously still a work in progress, and it's going to take many more iterations and versions of hardware to figure it out. Already you can see some problems with this. If you look down the tracks right here, you can see that they're bowed. So we have to figure out a way to be able to realign the tracks easily or have a gantry that can flex in some way so that if the tracks bow out like that, it's not an issue. So that's one challenge right off the bat. Another was probably going to be with the gantry being so wide, it's going to be heavier and it has more cables and tubing and water that it has to move around. And so we'll probably need a bigger motor to be able to move the gantry across, which then requires different electronics. So it just is going to require at least a few more prototypes at this size. Yeah, so I've always been building stuff. I mean, that's all these bikes I've made. Yep. This gate right here. This piece of metal right here was one of the tracks of the very first FarmBot. And now it's part of our gate. Yeah, so these solar panels right here and this little battery underneath have been powering FarmBot for 3 or 4 months now. So this is not connected to the grid. It is connected with the water and the Wi-Fi, but the power is all coming from these panels, which are just about $100. So with this setup, you can be pretty much totally self-sufficient. We also have this rain barrel over here that collects water from the rain. It doesn't rain here that much, so we don't collect a whole lot. But you could also, instead of having a valve that allows FarmBot to water, you could have a pump, and you pump the water from a pond or a big tank somewhere if you don't have municipal water.
So you're saying basically the water is maybe not self-sufficient, but if you could get the water there, it's self-sufficient. You just leave it and go pick your vegetables.
Yeah, exactly.
Because you're not seeding, you're not planting, are you turning the soil? I mean, is there something you still need to do?
I think really just the harvest at this point.
And at some point, it could harvest maybe?
Sure, I don't see why not. It's already this 3-axis machine that can, get into the right spot. It has a camera to identify stuff. It really just needs, I don't know, some pair of scissors and some type of grabbing mechanism. So there's no reason why it couldn't harvest.
It's kind of a universal gardener. You just need the right tools to attach to it.
Mm-hmm. Yeah. The tool mount also has electrical connections to it. So these tools have these screws right here that we use to pass electricity and signals through. And then these are wired up to our electronics down here. So this is the soil sensor, but you could also have a motor or a temperature probe or really anything else that uses electricity down in the tool. And then because this plastic base here, you can download that file. You can, using CAD software, modify it however you need, add little tabs and support structures or motors and sensors, and then you can just wire it up and tell FarmBot how to use it. See, why don't we just put the soil sensor in? Just like with the hardware, it's a platform where you can add your own tools, add different peripherals like pumps and lights and stuff. The software is the same way. If you want to tap into the weather to learn, is it going to rain tomorrow? The software can support that. If you want to use historical data from years past, maybe based on the sensors, you could do that. If you want to plug in some properties of your soil or your growing environment, you can do that as well. And then that allows FarmBot to farm smarter from the get-go and smarter over time. So now I can take this watering, or the soil sensor, and move it over to a spot that I want to measure the soil properties. And let's see, we could bring it down to, that's not quite where I want to go. Go back to where you were. Speared a leaf there.
How much would this cost if I wanted to, say, buy a kit?
Right now they're $2,900. The cost is comparable to a high-end 3D printer, so it's pricey, and over time that cost will come down. And if you were to build a lot of the parts yourself, you could save about $1,000. Almost everything's off the shelf. The parts that aren't off the shelf are the 3D prints, the plastic parts, and the plates, which are custom designed, though it's just a flat plate with holes in it, so you could produce it yourself fairly easily. And the other cool thing too is because it's so based in software, all of the functions, it will get better over time. So even if you bought a kit today, the hardware won't change, but the software will enable it to do more and more things over time. And with this tool system, you could create new tools or purchase new tools over time as they become available.
So you're really thinking about long-term, you're not thinking about the techie gardener.
Yeah, I think we have to start out with the techie gardener, the type of person who wants a project, who knows a thing or two about making, but we definitely want to move towards the average person. My long-term vision for FarmBot is that it's a home appliance, where just like everyone has a refrigerator and a washing machine and a dryer, maybe you have a FarmBot too. And it's just kind of in the background doing its thing. And it's like a utility that you use. You turn on the water on your faucet and water comes out. You go out into your backyard and there's food that has been grown for you. Then what's up to the end eater is just deciding what you want and what quantities and when throughout the year you're gonna want them. And that will, be somewhat based on the climate that you're in. FarmBot will make those recommendations. They'll say, this isn't gonna grow right now, it's just not the right time. Or this would be difficult to grow because of this condition of the soil isn't conducive for it. So there will of course be some limitations always because it's nature and you can only do so much with it. But yeah, the idea is a very easy to use system where really you're just dictating what you want to be grown. This is the promise of technology. You can use technology to make your life more comfortable and more easy to live. You can go and travel and have your garden take care of itself. And come back to really fresh, great food that is grown exactly how you want it to be grown.
That's right.
There's no reason to have to be reliant on big agriculture or the grocery store or to have to dedicate your whole life to growing some of your own food. And hopefully it puts that back as it's supposed to. Sometimes it doesn't though. Sometimes it misses.